Hey, physics fans, my Physics 12 class. Special video for you just to get you caught up on what we started with before spring break. On the Tuesday beforehand, on March 10th, here you go, Tuesday, last class on a Tuesday, we went over the beginnings of forces, the stuff that you learned in Physics 11. So there was lots of reading that we went through and all the stuff from actual Physics 11 worksheet that I did. Converted to grade 12 just as a review, and then talked about the three laws, Newton's three laws of motion, the first law, the second law, and the third law. Okay, that's all kind of review, and we did that on that Tuesday. There was this matching thing that I assigned, but it doesn't have to be done right away, but you should probably be able to do most of it right now by filling in those 24 words in different places. And then I assigned page 70 to 75 in the book. Go over it and do the examples. And I assigned page 76A and this one, all 8 of those questions due by that Friday. So some people took pictures of it and sent it in afterwards, and some people handed it in. And if you haven't done it, please do it. In fact, on that Friday, I went over some of those things. So we went over number 4 and how to do the system calculation and went all over that. Let's just zoom out on that. Zoom out to... So we went over number 4 and then we went over number 7 on that Friday. And then on page 117, the last question I assigned, there it is. So there's 4 of the answers there. If you got YouTube, you slow it down, and there you go. You can copy it all out. And I'd like to take a look at the book. This is what we have in the book. So Newton's first law and second law is talked about on those first 2 pages that I assigned. And this is just plain 3 F equals ma, very easy questions. And these are a little bit more challenging, so I'll do one of them right now. I'll do number 2 perhaps. Why not? Let's just zoom in into a single page, and that's... So this is it. A 20 kilogram rock is held. This has been assigned to you, so you've already done it, but just in case you haven't or didn't fully understand it, a 20 kilogram rock is held up by a cable that'll break if the tension in that cable exceeds 200 newtons, so it can hold 200 newtons. What upward acceleration will the string break? So we will draw our free body diagram. That's the tension in the string, and then there's a force of gravity pulling down. That's our free body diagram of the block. It is accelerating up, we're told. So what do? We write down what we're using. We're using Newton's law, and that's the sum of the forces is equal to F net is equal to ma. And the direction of the acceleration is the direction of the net force. And these are all vector forces. This is all one-dimensional, so we don't have to worry about trig and opposite angles and stuff like that. So the winning force is tension. Tension minus the force of gravity is going to equal ma. A is up, and it's winning. That's why force of gravity is negative, because it's the opposite way. It's a losing. The tension cannot exceed 200. So 200 newtons minus the force of gravity, which is mg, has to equal ma. 200 newtons minus the 20 times 9.8 has to equal the 20 times A. And that's what we're trying to solve. Okay, that's what we're trying to solve for. So 200 minus 196 is equal to 20A. So this is 4 is equal to 20A. So 4 over 20 is equal to A, and that is going to be 0.2 meters per second squared is equal to A. Am I right? Nope. I have to also include a direction. Even though we're told that it's up, it's an acceleration, it's a vector. So make sure that you include the upward direction. That's how you do it. Now, after that, let's talk about the different forces: the normal force, the tension force, the thrust force, and weight, and the friction force. Now, in Physics 11, we talked a lot more about the friction. And you should have read through all these examples as well. Just to give you a little bit of a scare, there's only one more page that I haven't assigned you to read, which is this one, which is on inclines, and we're not going to do the incline yet, incline plane. There's my inserted sheet of review questions that you have. I've already assigned 7 of those for you. And then there's the back side of that question, and then there's a review for the chapter. So the actual chapter is over as soon as we finish inclines, but we're going to go into depth on that friction and angles and stuff like that. So back to my handout. What I would like you to do is read through frictional forces and normal forces. Going through this, read through that gently and quick, and not gently, thoroughly. Go through it thoroughly, and the forces of friction. This is something that I do in Physics 12, go into a little bit more detail here. And this is the formula that we use for friction. We've already talked about that in Chapter 1 on static equilibrium when we had some friction going on in there. So I'd like you to calculate and do these questions. There they all are. Let's see, number 7. The driver of a 1,500 kilogram car puts on the brakes and skids with locked tires on a concrete road. Calculate the friction. So this is sliding. The tires are locked. And we can do on dry road, wet road, and icy road. And there's a coefficient of friction for dry, wet, and icy. So the force of friction is mu n, and the normal force, in this case on a level road, is mg. So this is going to be mu mg. Whew. Okay, and we have all those 3, and it'll get you the force of friction. Okay, now it says calculate the stopping distance traveling. So that makes it, what? How do you calculate the stopping distance? Well, the sum of the forces is equal to F net, which is equal to MA, and the only force acting on a car that's stopping, well, there's lots of forces. Here's a free body diagram. It's traveling that direction. So what do we have? Well, we have the normal force because it's on a surface, and there's a force of gravity, and there's a frictional force. It's moving this way, but friction is stopping it. What's pushing it forward? Nothing. It's called inertia. And inertia is not a force. So the force of friction is the only force. So when we add up all the forces, it's the frictional force, and that has to equal ma. So you now know what that number is because you calculated it. you have the mass, you can get the deceleration. You have the initial speed, and now it's going to come to a stop. So the final speed is 0, and you can have the acceleration. So you can calculate the stopping distance. Try out that one, and then read more about the coefficient of friction, sliding friction versus static friction, reading through it, please, understanding the difference between them, and then trying this question. If you go to the Moodle now, once that's done, then that's the handout. I'm just, in case you don't have it, on the Moodle, there's the handout. You can download it and see it. Let's see if it's going to pop up. There it is. It's asking us to download it. And then there's some videos here explaining what anti-lock braking systems are about. They're really good videos. So go through those. There's about 11, 12 minutes of videos there to watch. Plus this 11-minute video that we're working on right here. So, gosh, getting you to do about 20 minutes of watching and listening online and some homework. And get that done. Once we're done with that, where are we going? We're going on to the next, which is pretty easy. And that is going to be, whoops, let's load that up again. It's going to be on gravity. And that the force of gravity is not going to be the normal force anymore. It's not normal anymore, and we'll be playing around with that. So you can play around with that, read through the book a little bit on it too if you want. But we'll start on that on the next lesson. Thank you. Now, like, subscribe, leave the comments below, or leave the comments above. How about trying that? Anyhow, later.